Ethereum Sharding is a revolutionary scaling solution that uses parallelization to dramatically increase the network's capacity. In this video, we'll explore how sharding works and why it's crucial for Ethereum's future growth and mass adoption. Ethereum currently faces a significant scalability challenge. The network can only process around 15 transactions per second. This is extremely limited, especially when you consider that millions of users are trying to use the network simultaneously. As demand grows, this creates congestion, slow transaction times, and high fees. Sharding is designed to solve this fundamental limitation. So what exactly is sharding? Think of it as dividing the Ethereum blockchain into smaller parallel chains called shards. Instead of having one single blockchain processing everything sequentially, sharding creates multiple chains that work simultaneously. It's like upgrading from a single-lane highway to a multi-lane expressway, where multiple vehicles can travel at the same time without getting stuck behind each other. The key advantage of sharding is parallel processing. In the current sequential model, transactions are processed one at a time, creating a bottleneck. With sharding, multiple transactions can be processed simultaneously across different shards. Transaction 1, Transaction 2, and Transaction 3 can all happen at the exact same time on different shards, dramatically increasing the network's overall throughput and efficiency. In a sharded Ethereum network, there's a central coordination layer called the beacon chain. The beacon chain acts as the main coordinator, maintaining consensus and ensuring all shards work together harmoniously. Below the beacon chain are multiple shards, such as Shard 1, Shard 2, Shard 3, and so on. Each shard operates independently, processing its own set of transactions, while the beacon chain synchronizes everything and maintains the overall security of the network. Sharding brings several major benefits to Ethereum. First, it provides higher throughput, enabling the network to process thousands of transactions per second instead of just 15. Second, it leads to lower fees because increased capacity reduces congestion and gas costs for users. Third, it improves overall scalability, allowing the network to grow naturally with increasing demand. And fourth, it makes the network more accessible by lowering the hardware requirements needed to run a validator node, promoting greater decentralization. While sharding offers tremendous benefits, it also introduces some challenges that developers must address. Security complexity is a major concern, as each individual shard must remain secure against potential attacks. Cross-shard communication is another challenge, requiring efficient coordination when transactions need to interact across different shards. Finally, there's implementation complexity, as sharding requires significant changes to Ethereum's core protocol and architecture, making it a technically demanding upgrade. Sharding represents the future of Ethereum scaling. By enabling parallel processing across multiple shards, Ethereum can achieve the performance needed for true mass adoption. The vision is clear: a blockchain network that is faster, cheaper, and accessible to everyone around the world. Sharding is the key technology that will unlock Ethereum's potential to serve billions of users while maintaining its core values of decentralization and security.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.